So this is a talk that began as like an hour-long talk years ago about open source and its relationship to DevOps and 12-factor. And then as that's evolved and we've seen new trends kind of pick up, it turned into a 5-minute lightning talk, because that's all DevOps Days is doing now, about this subject of DevOps 12-factor platform engineering. Then 2 weeks ago, I was asked to give a 75-minute version of this talk at Dev2 Next out in Denver, and I gave that there. So this is now the IDPCON version of this talk, and it's gone through a lot of different iterations. For those who haven't met yet, by the way, I'm Justin Reock. I run DevRel for Cortex. Previous to Cortex, I was field CTO at Gradle. So the last few years, I've really spent just immersed in developer productivity theory, developer experience, and then previous, it was a lot of evangelism around open technologies and that sort of thing. So, all right. So where did DevOps come from? Like a lot of people will just kind of say, well, quite literally, it was the first DevOps Days, 2009, Ghent, Belgium. Thank you, Patrick Dubois, and thank you, John Willis, for bringing this amazing show to the US right after that. But I think that it actually started earlier than that. I think it started with a mindset, and I think it's this mindset, that it's no longer the big beating the small, but the fast beating the slow. All right, it's an older quote. It's become kind of a rallying cry for DevOps, but I think it's the right mentality. It means it's no longer bigger is better, right? It's the agile companies that can react quickly to the demands of the market, the demands of their customers that are going to win. So to explain why this works, I'd like to revisit the ancient business wisdom of the 1970s and 80s. We've already heard a little bit from Deming today from John Willis's talk. And I want to focus on a guy who was really inspired by Deming. Some of you may have heard of Eli Goldratt or have read the book The Goal. Anybody in here? We mentioned the Phoenix Project earlier. How many people know that the Phoenix Project is a direct homage to The Goal? Right? It's the same type of hero's journey, right? Except The Goal takes this from a standpoint of manufacturing, because that's what was big when Eli Goldratt was talking about this stuff. And all of these things, DevOps, Agile, Lean, they extend from the work of these two folks, statisticians and physicists, scientists, right? Who realized, they had an intellectual leap. They realized that a business is a complex machine. And complex machines are guided by various laws of physics. And you can't break the laws of physics. So if we start doing these things, we can actually make very accurate predictions about the way an organization or any other complex machine is going to work. And he boiled all this down into a theory called the theory of constraints, right? Which is also introduced in the Phoenix Project through the change agent in that story. And here's the Phoenix Project. Again, direct homage to The Goal. Gene Kim will be the first to admit that. In fact, I think, John, if I remember correctly, he even gave you the advice to read The Goal before reading the Phoenix Project. Is that correct? I would totally echo that, to see the essence of where all this sort of came from. For those who haven't read the Phoenix Project, again, it's a fiction, not a business novel. A page-turning story about a VP of software engineering struggling to keep pace, and the introduction of DevOps and Agile and how that changes the business. So it's an excellent book, and it's a page-turning read. It's not like a business kind of textbook. The theory of constraints is complex, but one of the biggest principles is that you can boil complex machines, and this is more of machine physics, down to three sort of basic subcomponents. There's a cost to that machine, right? The energy, the fuel that it takes, whatever it makes to actually make the machine do what it's supposed to do. There's an inventory to that machine, okay? So the working parts that work together to make the machine like do something. And then there's the throughput of that machine, actually doing what the machine is supposed to do, right? So if you take like a lawnmower, for instance. What's a lawnmower, right? It's like a spinning blade, and you got a motor, and you put fuel in it, and that's your cost, and maybe you push it, or maybe you have one of those cool robotic ones now. But either way, electricity, energy, fuel is making this lawnmower move, and what's it doing? Well, hopefully it's cutting grass, and hopefully it's cutting a lot of grass fast, because without that, it's just a pile of fuel and inventory. So what the theory of constraints says is that throughput is actually the most important subcomponent of these machines. Right? Throughput. Because without throughput, the machine doesn't really have much of a purpose. Now, the intellectual leap in the theory of constraints says, how do we take these three subcomponents and map them to a business, an organization, right? Well, cost is still cost. That's organizational cost, right? That's work being done to create, hopefully, a product from the inventory of that machine. And then that throughput is money in the case of a business, right? What's the job of a business? It's to make money. So where Goldratt said that we were getting things wrong was that we tended to prioritize cost. We would do things like massive layoffs to try to fix a company, but we know that that doesn't improve throughput. In fact, it ruins it in a lot of cases. You have brain drain and things slow down. So what this really teaches us is that the only initiatives that will positively impact long-term performance are the ones that increase throughput while simultaneously decreasing cost. Okay? So when we think about things like engineering excellence, when we think about things like developer experience, right, we're really thinking about clearing bottlenecks to throughput. And there are so many of those, right? But if we have a lucrative business that ships software features, then that increased throughput should lead to accelerated profits for that business. And I think this is something that we don't talk about enough. I think we often look at developer experience fixes as like a cost optimization, and it really is a throughput optimization. It's really about getting our engineering organizations to be able to ship better software faster, right? Software faster. It also gives us a basis for continuous improvement. Back in physics again. Little thing called the second law of thermodynamics that we all fight. Some of us, like Deming, have figured out how to master entropy. A lot of Deming's inspiration towards variability was his love for quantum mechanics, which teaches us that we live in a probabilistic universe, right? And because of that, second law of thermodynamics says that we are always outrunning entropy. Things don't sit still. Nothing sits still, right? It rots. So when we're fighting entropy and we're just trying to continually improve, and this is where that adage of it doesn't really matter what you're improving as long as you're constantly improving something, because you're basically outrunning entropy at that point. It also means that if we want to achieve the goals in the theory of constraints, that we need to think about how do we lower the distance between the actual cost and inventory, the work in progress that's being managed by that business, and then the speed at which that code actually gets out into the world making money for the business. All right? That's really been the essence of what DevOps theory tries to do. The cost and inventory assembly, hands-on keyboard, is kind of useless and even increasing in cost because of entropy and because of code rot until it ships, right? And so we put all this work into automating that part in the middle, right? But maybe not enough of the dev side as we're learning about. So this is why we ended up here with our wonderful DevOps conveyor belt. This is just one of many representations of a DevOps pipeline. But we have this conveyor belt that's always moving forward, right? Never moving backwards, right? We don't pull releases anymore. If we release a bug, we just release a fix 2 seconds later, right? And it's that conveyor belt mindset that has gotten us to really thinking about being more throughput driven in terms of the way that our organizations work, right? That's very much the point of it. Okay, so DevOps conveyor belt, theory of constraints, reducing distance between cost and throughput. That's great. Where does free software win here? How come free software has become so much of the platform, right? Well, you know, everybody's kind of heard like free as in free speech, free, not as in free beer. And that's really interesting, right? Like the freedom to do more stuff with the software. I think the last decade has taught us it's more like free puppies. You know, who doesn't love puppies? But you got to feed them, you got to take care of them. There's a debt there, right? But the frictionless way in which engineers have been able to get their hands on high-quality software, a lot of this has been because of what open source has given us. And this is not a new phenomena, all right? A lot of folks might recognize Pythagoras. Or you might at least know a squared plus b squared equals c squared, right, to calculate the hypotenuse of a right triangle, which is, I think, the only thing I remember about geometry. But what a lot of folks don't know is that Pythagoras was running a school of geometry in ancient Crotone, which is sort of southern Italy. And you have to understand, geometry was not commoditized back then. Right? Geometry was the secret esoteric math language that was building all the infrastructure of the time. Right? It was allowing civilization to exist, much like code kind of does for us now in a lot of sort of virtual infrastructure, if you'll kind of forgive that metaphor. The problem was Pythagoras split his school into an inner circle and an outer circle. You had the inner circle, which were the mathematicoi. They were the learners. They were the only ones that were actually allowed to learn and practice geometry. And then you had the outer circle of that school called the acousmatics, or the listeners. And they were like glorified sort of errand people for the school, but they weren't really learning geometry. And then you had a whole crazy thing going on the outside called civilization, where you had people who believed in crazy stuff like nobility and birthright, who thought that they should be allowed to learn geometry, but they weren't, right? So this stuff, which was critical for building the infrastructure of the time, was considered esoteric and secret, and made a lot of people angry. Now, you juxtapose that to a guy like Sir Isaac Newton, and more importantly, the publication of Principia Mathematica, which is, in my opinion, one of the first times engineering knowledge has been put into the public domain. So Sir Isaac Newton saw things differently. He said, if I can share what I've learned with other mathematicians and engineers and scientists, maybe we can move the world forward, right? And that's where the rise of the public domain came from. Things did not end well for Pythagoras. A lot of times we don't learn this story in school. He died in exile. There was a guy named Cylon, one of those noble people that I was talking about, who believed that he should be allowed into the school. Pythagoras arbitrarily said, nah, you can't really learn geometry. So Cylon led a revolt, killed a bunch of his students, and Pythagoras died in exile. Meanwhile, the more free and open approach led to things like the Florentine Bodega, which was a symposium of scientists and thinkers and philosophers and poets and artists and sculptors all coming together, right? Kind of like a GitHub almost. But this was where open communities became, again, things that would lead into the public domain. And it was this way of thinking that would bring down the nobility. It would tear down the nobility. It would lead to reductionism, scientific method, the belief that we're all a clean slate. Leonardo da Vinci was discovered at one of these. Okay, so we got DevOps, we got a pipeline, we're understanding throughput, we got free software, it's easy to get our hands on, it's easy to deploy, right? How has all this changed the way that we have to write software? Who's familiar with the 12 factors? Okay, good number of folks. These are being rewritten. James Ward at Google is leading an open public community of folks right now to kind of revisit this wisdom. If you want to get involved, look up James Ward, or you can talk to me and I'll tell you how to get involved. The 12 factors are a way of providing a framework, and we learned about frameworks earlier and what they actually are, for making sure that your apps are as portable and sort of cloud-friendly as possible. Now, I'm not going to suggest that if your app isn't like fully 12-factor that you're not going to go to cloud. That's not what's going to happen, right? But there is sort of an inverse relationship, right? You should expect more friction in your deployment the less 12-factor your app is, right? And it's because of what these 12 factors sort of cover. Like, for instance, keeping the code base in one place and issuing all of our builds out of that. It's really, really hard to do automated CI/CD when your code's in 20 different repositories, right? Arguably, you can clever your way through that, as many people have. But let's try to keep our code in one code base. Let's explicitly declare and isolate our dependencies, right? Let's put them in our package.json or our build.gradle or pom.xml or whatever the file is where we can go and say we need to grab these external dependencies from elsewhere so that when we deploy, we always know where those dependencies can come from, but we don't have to store them in source control. We should also store our config in the environment, more and more in environment variables, because they're easy to inject into an environment. They're ubiquitous. A lot of this stuff is just making sure that no matter where you deploy your code, it's going to be observable, it's going to be performant, and all these things, right? This is the whole unlocking a multi-cloud strategy and all that. Treat backing services as attached resources, right? So almost through an API layer or whatever. Build, release, run. Separate these phases. Believe it or not, we didn't always do this. Those of us who have been writing code since the late 90s know that this wasn't always separate, right? There weren't distinct build, release, run sets. Run your processes as single-threaded processes, again, so that they can easily be controlled by a ubiquitous process manager, and so that they don't clobber each other. Use port binding because it's ubiquitous, TCP. Another example of a great open, could you imagine what the world would be like if TCP was closed? Like, we certainly wouldn't have this. But use port binding, use TCP ports to bind to services, because it's ubiquitous, because everything does TCP. Concurrency, use the process model to have separate, isolated, concurrent processes so that you can run them isolated in a container across multiple clouds and no one will care. Make sure that your processes are fully disposable. They should come up cleanly, and they should destroy themselves and leave no trace. And that, again, allows you to restore cloud resources and easily deploy on cloud substrates. Dev prod parity, Docker kind of fixed this for us, but believe it or not, production didn't always match where we were developing. We had a laptop that was probably 10 years old, and we would compile our app, and put it on like we didn't have USB sticks, put it on a drive, walk it down to another building, maybe the QA team launches it up in a totally different environment, and then they come back a week later and tell you it didn't work, and it was like that. And then Docker kind of made sure that no matter where you're building your app, as long as you're running within a compatible container engine, you're basically going to have the same conditions. Is it always perfect? No, but it's definitely better. Logs. Treat logs as event streams, because we've got 18 layers of abstraction now between the app and the actual ingress-egress points, right? Don't force your administrators to log into 18 different systems just to pull out one line of a log, right? Treat these as event streams, push them out, right? Push them out into systems that can aggregate that data, make it easy to visualize. And then finally, run admin processes as single process threads within the same app. Don't just run stuff on the command line, right? Again, not portable, not ubiquitous, and not guaranteed to work the same way in multiple places. So, we got 12 factors. We got DevOps. We got free software. We've decomposed all of our monoliths into microservices to make our cloud deployments less complex, right? That's why we're all here, because things are so good. Yeah. No. All of this freedom and portability has led to more complexity and disorganization, which has led to what do we hate? Toil, friction, and context switching. Right? Always brings us right back to this. This is the state of the art. I got microservices, mini-services, monoliths. I'm tracking them through spreadsheets, Google Sheets. When people leave, I don't know about it. I don't know where ownership is. I don't know where any of my stuff is. When something breaks, I'm not sure what Slack channel to go to. This is the state-of-the-art platform right now. This is the state-of-the-art portal. I think we can do better. Yeah, we don't need to be managing 200,000 microservices on a single spreadsheet. We can do better than that. This is now the problem statement. This is the CNCF Cloud Native Compute landscape, a brilliant, beautiful resource of everything you can possibly build your platform with. And if I was a newly minted platform engineer, I would look at this and definitely get a different job. But this is where we are. We are building platforms now. And what is the platform? There is no one platform, okay? It's just some sort of permutation of all these different bits of the palette that I just showed you. We're going to put together something like that. But it's not a dev tool chain anymore. And it's not a DevOps pipeline anymore. It's not just a CI/CD pipeline anymore. Because why? Because we're doing platform engineering now, right? We're bringing in parts of the developer experience too. We're trying to be inclusive of the whole process of creating code, right? And I think that we have to adopt really sort of a triple threat mindset here. I think the best platform engineers deeply understand DevOps, and that's another point that I want to make here, is that these are not mutually exclusive things, right? There are so many elements of DevOps that you'll find throughout platform engineering. I think you have to have a deep passion for developer experience, like we just heard about for this, from this panel, and not only have a passion for it, but understand the knock-on effects of better developer experience. But then finally, and we're going to talk a lot about this, not just today, but also in the future, you have to establish a product management mindset. You are building a product for a customer. That customer just happens to be your developer or your engineer that's working for you. But you should treat quality and feedback and all of those things with the same rigor that you would treat a product that you were shipping to a customer. You should take their feedback seriously, and you should use that to plan the next iteration, and you should launch iteratively, okay? What are IDPs? Well, we learned a lot about those today. This is the choreography layer to the platform. That's the way that I like to think about it, and give me a chance to explain that. Oh, did you want? Here, go for it. Give me a chance to explain that. So I think that when we started automating manual tasks, like forever ago, we were talking about the automation usually of one thing. Somebody's got to copy a file on Saturday at 2 a.m. All right, let's write a little bit of automation to do that. Then we started grouping bits of automation together into central places, an orchestration, like centrally organized stuff. So like what do you got, like Kubernetes? Perfect example of something that's an orchestrator, right? It's a container orchestrator, all this different automation. But it's central. Choreography has traditionally been sort of the third layer of that automation, and this is where there's no centralization anymore. There's no one central authority. Dancers on stage aren't all taking their cues from one person. They're looking at each other, looking for their own tempo, making eye contact with one another, figuring out what they're supposed to do next. And this is how microservices choreograph one another. They send out events to each other instead of just having one central platform. But an IDP allows developers to choreograph the platform. Whenever they want, 3 a.m., feeling creative, want to get some work done, need an environment to do it, you can log into your portal, no one's blocking you. You can choreograph the portal on your own terms and transparently. I like to think about it that way. And of course, everything gets to live in a single system of record. And this unlocks like a lot of really interesting stuff. I think part of the reason that it's been hard to define the space is because we tend to think in use cases, and there are so many different use cases for a portal. They fix so many different types of problems. But I think thinking about it this way, as having a single system of record that we can all collaborate with, allows us to unlock all kinds of other stuff. Better service catalogs, better developer self-service, better production readiness, security compliance, engineering intelligence, and better platform modernization. It allows us to get out of situations like this. Who loves production readiness assessments? Just the best, right? Sit in a call for 4 hours, speak for all of 2 seconds when it's time to ask if your box has been checked, right? But a portal can aggregate all of that same information that you would normally have to go check manually, put it in one place. Do you know what production readiness assessments look like for people who are running IDPs or portals like Cortex? They don't look like anything. There's just one green line on a screen that says, okay, we can go. And we have some businesses that have even moved to a level of maturity where they'll gate their own releases based on API calls to the portal and say, well, I know you want to push this, but hold on, we're not production ready yet, we got to wait. Okay? It's awesome. It's just one of many, many use cases that we can, that we can unlock. So scorecards, in our case, are how we've chosen to unlock that. This is sort of, again, a really nice use case for something that's well choreographed, where we're already integrating with all the parts of the platform that we would need to assess for readiness anyway. So PagerDuty, Slack, BuildKite, SonarQube, Jira, GitHub, Sneak, I did them all. They are all systems that we would hopefully be integrated with, and we can just evaluate, is this service actually ready? And we can gamify the metrics too. This is one of my favorite parts. This is a lot of the reason that I came to Cortex, to be honest, is this pattern and how powerful it is at solving socio-technical challenges, which, as you'll see, is sort of the theme of the day. We can actually say, these standards in this evaluation will get your service as a developer to bronze or silver or gold. And we all want to be gold, right? But it's not a boss telling you, hey, your standard is wrong, you need to go fix this, right? It's just the portal saying, you got this service that you own and it's at silver standard right now, and if you go fix these 2 things, it'll be a gold, right? But people can collaborate on these cross-functionally. So imagine that I've got a readiness assessment. Let's look at this one again. SonarQube code coverage over 90%. Okay, sure. Let's say that we want to bump that to 95% across an organization of 20,000 engineers spread across 1,000 different teams. Where are you going to update that? How are you going to cascade that? Is that going to come in a monthly announcement? No. So if you update it here in a scorecard, though, you literally tweak this one little rule, and that cascades down to every engineer who's using this portal. And they immediately know that the standard has changed, and they don't even necessarily know the standards have changed. They just saw that their score went from gold to silver, and they better go and do something about that. Okay. It also makes DORA and other engineering intelligence metrics, as we're learning today, there's lots of different metrics we should be paying attention to. But when we're already integrated with all these systems, it just makes it so much easier to roll all this stuff up, right? So it also unlocks, I would say, much more straightforward and easier engineering intelligence. So quick recap here. DevOps definitely finds its roots in the theory of constraints, in machine theory. And the reason, again, that I love this so much is that you're either making a right prediction or you're breaking the laws of physics, right? So if you structured this correctly, you can really get some good intelligence about your business. Without free software, building modern platforms would be incredibly difficult. I might even say impossible. 12-factor principles can help you take advantage of these modern platforms, and there's a new one in the works that keep an eye on. Platform engineering unites DevOps, DevX, and product management. 3 disciplines kind of into one, I think, is what it takes to be a very good platform engineer. And a good internal developer portal gives shape to an internal developer platform. I think it's almost fair to say that it's not even really a platform without that portal interface, because otherwise it's a DevOps toolchain or a DevOps pipeline or something like that. And then finally, we do have a podcast. So Lauren, is Lauren here or is she out in the main room? Lauren is my co-host, and we, every month, are releasing an episode about other folks who are in this space. John has been on the podcast, Max has been on the podcast, and we are definitely seeking more people to come on. But if you're interested in learning about this stuff, we're dropping new episodes every month, and I'm really proud of the folks that we've been able to curate for this. All right, let's go have lunch.